This question says, which of the following cannot be the valid assignment of probabilities for the outcomes of the sample space omega 1 to omega 7? Let's begin with the solution. And first let us solve the first part. In the A part, as we can see here, each assigned value is non-negative and the sum of all the values, that is 0.1 plus 0.01 plus 0.05 plus 0.03 plus 0.01 plus 0.2 plus 0.6 is equal to 1.00, which is equal to 1. Hence we can say that the given assignment of probabilities is valid. Now let us move on to the second part. Here again we can see that all the values are non-negative. Now we have to find their sum. Sum is equal to 1 upon 7 plus 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 1 upon 7, and this is equal to 1. And since all the values are non-negative and their sum is 1, therefore in this case also we can say that hence the given assignment of probabilities is valid. Now proceeding on to the C part. In the C part also we have all the values non-negative, right? All values are non-negative. Now let us find the sum. Sum is equal to 0.1 plus 0.2 plus 0.3 plus 0.4 plus 0.5 plus 0.6 plus 0.7, and this is equal to 2.8, which is not equal to 1. Here the given assignment is not valid since the sum is not equal to 1. The given assignment of probabilities is not valid. This completes the C part. Now let us move on to the D part. In the D part, as we can see that the value assigned to omega 1 and omega 5 are negative, therefore the given assignment of probabilities is not valid in this case. So this is the answer to the D part. And now let us proceed on to the last part. Here, as we can see, all the values are non-negative. Now let us find the sum of all the values assigned to omega 1, omega 2, omega 3, omega 4, omega 5, omega 6 and omega 7. So we have 1 upon 14 plus 2 upon 14 plus 3 upon 14 plus 4 upon 14 plus 5 upon 14 plus 6 upon 14 So here we have last value as 15 upon 14, and this is equal to 36 upon 14, which is not equal to 1. Also, since 15 upon 14, which is the value assigned to omega 7, is itself greater than 1. Therefore, the given assignment of probabilities is not valid. Hence, the given assignment of probabilities is not valid. This completes the solution, and we see that only part A and B has valid assignment of probabilities. So, C, D and E cannot be the valid assignment of probabilities for the outcomes of the given sample space. This question says that a coin is tossed twice. What is the probability that at least one tail occurs? Let's begin with the solution. And when a coin is tossed twice, then the total number of possible outcomes is equal to 2 square, which is equal to 4. We have got 2 squares since when a coin is tossed, there are 2 possible outcomes, and here a coin is tossed twice. Therefore, we have 2 raised to the power 2, and this results equal to 4. Now, we have to find the probability that at least one tail occurs. So first, let us write down the sample space for this experiment. Both the head can appear, head and a tail can appear, and first tail and then a head can appear, and then both the tails can appear. Now, let E denote the event that at least one tail occurs. Then, the event E is equal to at least one tail occurs implies we have head tail, tail head or tail tail. In these 3 outcomes, we have at least one tail. Therefore, probability of the event E is equal to number of the favorable outcomes to the event E divided by the total number of outcomes. Now here, the number of favorable outcomes are 3 and the total number of outcomes are 4. Hence, the required probability is 3 upon 4. This completes the solution. This question says that a die is thrown. Find the probability of the following 5 events. So let's begin with the solution. And we know that when a die is thrown, there are 6 possible outcomes. Let us write down the sample space. So the sample space for this experiment is the numbers which appear on the faces of the die, which are 1, 2, 3, 4, 5 and 6. Let us now find the solution to the first part. In the first part, we have to find the probability of the event that a prime number will appear. So let A denote the event that a prime number will appear. So this implies A consists of the sample points 2, 3 and 5. Now let us find the probability of the event A. So this is equal to the number of favorable outcomes divided by the total number of outcomes Now the favorable outcomes are 3 to the event A. So we have 3 upon the total number of outcomes, which are 6. So this is equal to 1 upon 2. Hence, the answer to the first part is, hence the probability is 1 upon 2. Now let us proceed on to the second part. In the second part, we have to find the probability that a number greater than or equal to 3 will appear. So let B denote the event that a number greater than or equal to 3 will appear. So here the set B will have the sample points 3, 4, 5 and 6. Now let us find the probability of B. Probability of B is equal to the number of favorable outcomes to the event B divided by the total number of outcomes so this is equal to the number of favorable outcomes to the event B are 4 and the total number of outcomes are 6. So this is equal to 2 upon 3. Hence, the required probability is 2 upon 3. Now let us proceed on to the third part. In the third part, we have to find the probability that a number less than or equal to 1 will appear. So let C denote that a number less than or equal to 1 will appear. So the set C will have only one sample point, and that is 1. Therefore, probability of C is the number of favorable outcomes to the event C divided by the total number of outcomes and here the number of favorable outcomes is 1 and the total number of outcomes are 6. Hence, the required probability for the third part is 1 upon 6. Now moving on to the fourth part. We have to find the probability that a number more than 6 will appear. So let D denote that a number more than 6 will appear and there is no number more than 6. Therefore, D is an empty set, or we can say that D is an impossible event. Hence, probability of D is equal to 0. So in this case, the required probability is 0. Proceeding on to the last part. Now, in this part we have to find the probability that a number less than 6 will appear. So let E denote the event that a number less than 6 will appear. So in this case, set E will have sample points 1, 2, 3, 4 and 5. These numbers are less than 6. Therefore, probability of event E is equal to the number of favorable outcomes to the event E divided by the total number of outcomes. Now the favorable outcomes in this case is 5 and the total number of outcomes are 6. Hence the probability that a number less than 6 will appear is 5 upon 6. This completes the solution. This question says that a card is selected from a pack of 52 cards. We have to find that how many points are there in sample space. Calculate the probability that the card is an ace of spades, and also we have to calculate the probability that the card is an ace or a black card. Let's begin with the solution. And we know that in a pack of cards there are 52 cards. Right? Therefore, the total number of possible outcomes are 52 when a card is drawn. Therefore, our answer to the first part is sample space contains 52 points. Now let us proceed on to the second part. In the second part, we have to find the probability that a card is an ace of spade. Now, we know that in a pack of cards, there are 4 types of cards. There are 13 spade cards. There are 13 diamond cards. There are 13 club cards. And there are 13 heart cards. And each type of a card has one ace in it. and we have to find the probability that the card is an ace of spades. So let E denote the event that an ace of spade is drawn. Therefore, probability of the event E is equal to the number of favorable outcomes to the event E, and there is 1 ace, so we have 1 upon the total number of sample points in the sample space, which is 52. Hence, the required probability is 1 upon 52 that an ace of spade is selected. Now let us proceed on to the C part. In the C part, we have to find the probability that the card is an ace card and second, a black card. Now, first, let F denote the event that an ace card is selected. Now, as we have seen above, all the 4 types of cards have 1 ace. Therefore, the total number of ace cards are 4. Now let us find the probability of F. So this is equal to the total number of ace cards, which is 4, divided by the total number of cards, which is 52, and this is equal to 1 upon 13. So this is the first part. Now let us find the probability that a black card is drawn. So let G denote the event that a black card is drawn. Now, from the pack of cards, we know that the spade cards are black in color and the club cards are black in color. Therefore, in all there are 26 cards which are black in color. So we have total number of black cards is equal to 26. Therefore, the probability that black card is selected is given by probability of G, which is equal to the total number of black cards in the pack of cards, which is 26, divided by the total number of cards, and this is equal to 1 upon 2. Hence, the probability that an ace card is drawn is 1 upon 13 and that a black card is drawn is 1 upon 2. So, this completes the solution. This question says that a fair coin with 1 marked on one face and 6 marked on the other and a fair die are both tossed. Find the probability that the sum of the numbers that turn up is 3 or 12. Let's begin with the solution. Now we know that when a coin is tossed, there are 2 possible outcomes, a head and a tail. Suppose on the head side, 1 is marked and on the tail side, 6 is marked. So with this fair coin, a die is also tossed. So first let us make the sample space. First the coin is tossed. So the outcome is either a head or a tail, that is 1 or 6. Then a fair die is tossed. So after this there are 6 possible outcomes, and we have 1 1, 1 2, 1 3, 1 4, 1 5 and 1 6. Similarly, again the die is rolled after the head gives 6. So again after this there are 6 possible outcomes. So we have 6 1, 6 2, 6 3, 6 4, 6 5 and 6 6. Hence the sample space consists of the following outcomes, and these outcomes are 12 in number. Now we have to find the probability that the sum of the numbers that turn up is 3. Now the probability that the sum of numbers is 3. There is only one sample point. The sum of the numbers of which is 3. 1 plus 2 is 3. So we have only one sample point. So we have 1 upon, which is the favorable outcome, such that the sum of numbers is 3, divided by the total number of possible outcomes, which are 12. Hence the required probability for the first part is 1 upon 12, that the sum of the numbers turn up 3. Now let us proceed on to the second part. In the second part we have to find the probability that the sum of numbers is 12. Now from the sample space we can see that there is only one outcome such that the sum of the numbers is 12, and that is 6, 6. This is the sample point, and this exists only one time. So the number of favorable outcome is 1 divided by the total number of possible outcomes, which is 12. Hence the required probability in this case is also 1 upon 12. So this completes the solution. This question says that there are 4 men and 6 women on a city council. If one council member is selected for a committee at random, how likely is it that it is a woman? Let's begin with the solution. And we are given that there are 10 members in the city council, out of which 4 are men and 6 are women. Right? We have to find the probability that if one council member is selected for the committee at random, then it is a woman. So here we can see that the total possible outcomes is the total number of members in the city council, which is equal to 10, and the number of favorable outcomes such that a woman is selected, and that is equal to 6. So we have 6 upon 10, and this is equal to 3 upon 5. Hence the required probability that a woman member is selected at random is 3 upon 5. This completes the solution. This question says that a fair coin is tossed 4 times and a person win rupee 1 for each head and lose rupees 1.50 for each tail that turns up. From the sample space, calculate how many different amounts of money you can have after 4 tosses and the probability of having each of these amounts. Let's begin with the solution. And we know that when a coin is tossed, the possible outcomes are 2, and here the coin is tossed 4 times. Therefore, the total number of possible outcomes is equal to 2 raised to the power 4, which is equal to 16. So let us now find the sample space for this experiment. When a coin is tossed, the possible outcomes are a head or a tail. Now when the coin is tossed once again, then a head may be followed by a head, or a head may be followed by tail. Now the coin is tossed once again, so from here we again have 2 possible outcomes, head, 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 and a head, head, tail. Again the coin is tossed, since the coin is tossed 4 times, so this is the last time the coin is tossed for this branch. So we have H, 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 T, or H, 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 H. That is, a tail may appear at the 4th toss, or a head may appear. Similarly, from here we have head, head, tail, head, and head, head, tail, tail. So similarly, from here also we get 2 events, and this way the sample space is as follows. So this is the required sample space when a fair coin is tossed 4 times. Now let E omega be the amount of money corresponding to an outcome of the sample space. Let it be omega, which belongs to S. Then let us find now the value of E omega. First, for omega, 4 times H. So this is equal to, now here 4 times head appears, so the person wins rupee 1 4 times, that is rupees 1 plus 1 plus 1 plus 1, and this is equal to rupees 4. Now let us find the amount of money corresponding to the next outcome, which is HHHT. Now notice that in HHHT there are 3 heads and 1 tail. Similarly, in head, head, tail, head, we have 3 heads and 1 tail. In head, tail, head, head, we have 3 heads and 1 tail. And in tail, head, 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 we have 3 heads and 1 tail. Therefore, the amount of money corresponding to these 4 outcomes will be the same. That is E HHHT is equal to E HHTH is equal to E HTHH is equal to E THHH, and this is equal to rupees. Now there are 3 heads, therefore we have 1 plus 1 plus 1 and 1 tail. So he loses 1 rupee 50 paisa, therefore we have minus 1.50, and this is equal to rupees 1.50. Now let us find the values of the other outcomes. Now notice that in the next outcome we have 2 heads and 2 tails. Similarly, for the next one also we have 2 heads and 2 tails. For the next one also we have 2 heads and 2 tails. For this also we have 2 heads and 2 tails. And for this also we have 2 heads and 2 tails. And here also we have 2 heads and 2 tails. Therefore, for 6 outcomes we have 2 heads and 2 tails. Therefore, the amount of money corresponding to these 6 outcomes will be the same. Hence we have E HHTT is equal to E, HT is equal to, and so on. And this is equal to rupees. We have two heads, so 1 plus 1, and we have two tails, so minus 1.50 minus 1.50, and this is equal to rupees 2 minus rupees 3. So here we have a loss of rupee 1. So let us write it as minus rupee 1. Now let us again see the sample space. Then the next outcome is HTTT. Here we have 3 tails and 1 head. In the next outcome also we have 3 tails and 1 head. In the next one also we have 3 tails and 1 head. And in the next one also we have 3 tails and 1 head. Therefore the amount of money corresponding to these 4 outcomes will also be equal. And thus we have E, HTTT is equal to, and so on is equal to, here we have 1 head, so we have 1, and 3 tails, so we have minus 1.50, minus 1.50, and minus 1.50, which is equal to minus rupees 3.50. That is, here the person has a loss of rupees 3.50. And now let us find the value for the last outcome, which is tail, 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 tail. So here the amount of money for this outcome is equal to rupees. Now since there is a loss of rupees 1.50 paisa, so we have minus 1.50 4 times, and this is equal to minus rupees 6. So if 4 tail appears one after the other, then the person loses rupees 6. Now according to the question, we have to find the different amounts of money you can have after the 4 tosses. So the different amounts of money is a gain of rupees 4, a gain of rupees 1.50, a loss of rupee 1, a loss of rupees 3.50, and a loss of rupees 6. So our answer is, hence, the different amounts of money are gain of rupees 4, gain of rupees 1.50, loss of rupee 1, loss of rupees 3.50, and a loss of rupees 6. Now let us find the probability of each of them. First let us find the probability of the gain of rupees 4, and from the sample space we see that the gain of rupees 4 is from the one outcome of the sample space, that is HHHH. Therefore the number of favorable outcomes for this event is 1, and the total number of possible outcomes are 16. Therefore probability for the gain of rupees 4 is 1 upon 16. Now let us find the probability for the gain of rupees 1.50. Now the gain of rupees 1.50 is from the 4 outcomes of the sample space. Therefore the total number of favorable outcomes for the gain of rupees 1.50 is 4, and the total number of possible outcomes are 16. So in this case the probability is 1 by 4. Now let us find the probability for the loss of rupee 1. Now from our calculation we see that a loss of rupee 1 occurs from the 6 outcomes of the sample space. So in this case the number of favorable outcomes are 6 and the total number of possible outcomes are 16. So in this case the probability is 3 upon 8. Now let us find the probability for the event loss of rupees 3.50. And again, from our calculation we see that there are 4 outcomes for which the person suffers a loss of rupees 3.50. Therefore, the favorable outcomes are 4 and the total number of outcomes are 16. So this is equal to 1 upon 4. Now, the probability for the loss of rupees 6 is given by the number of favorable outcomes. Let us see from the calculation. There is only one outcome for which a person suffers a loss of rupees 6. So we have 1 and the total number of outcomes are 16. So we have 1 upon 16. So these are the required probabilities of the gain and loss suffered by the person. So this completes the solution. In this question we are given that 3 coins are tossed once. Find the probability of getting 3 heads, 2 heads, at least 2 heads, at most 2 heads, no head, 3 tails, exactly 2 tails, no tail, and at most 2 tails. So let's begin with the solution. Before finding the probability, first let us find the sample space when 3 coins are tossed once. Now we know that when a coin is tossed, the possible outcomes are a head or a tail. So here 3 coins are tossed. Therefore, the total number of possible outcomes is 2 raised to the power 3. Which is equal to 8. Therefore, the sample space of the experiment will have 8 outcomes, which are as follows: head, 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 tail, head, tail, head, tail, head, 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 tail, 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 head, tail, 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 head, and tail, tail, tail. First, let us find the probability of getting 3 heads. Now, from the sample space, we see that there is only one outcome having 3 heads. Therefore, we have only one outcome given that 3 heads appear, and the number of favorable outcomes to the probability that 3 heads appear is 1, and the total number of outcomes from the sample space are 8. Therefore, probability of getting 3 heads is 1 upon 8. Now let us proceed on to the second part. In the second part, we have to find the probability of getting 2 heads. Let us see the sample space now. Here we have 3 outcomes when we get 2 heads, which are namely head, head, tail, head, tail, head, and tail, head, head. So, the number of favorable outcomes such that 2 head appears are 3 from the sample space, and the total number of outcomes are 8. Therefore, probability that 2 heads appear is 3 upon 8. Now let us find the solution to the third part, which is to find the probability that at least 2 heads. Now, at least 2 head means that the number of heads should be greater than or equal to 2. Now, let us see from the sample space. Now, the sample space, as we can see, there are 4 outcomes such that the number of heads are greater than or equal to 2, which are HHH, HHT, HTH and THH. Therefore, this is equal to probability of the events HHH, HHT, HTH and THH. So, the number of favorable outcomes in this case is 4 and the total number of outcomes are 8. So, this gives 1 upon 2. Therefore, probability that at least 2 heads are there is 1 upon 2. Now let us proceed on to the fourth part. In the fourth part, we have to find the probability that at most 2 heads appear. Now, at most 2 head means that the number of heads is less than or equal to 2. And from the sample space, we see that for all the outcomes except HHH, the number of heads are less than or equal to 2. Therefore, in this case, we have the probability of events head, head, tail, head, tail, head, tail, head, 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 tail, 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 head, tail, 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 head and tail, tail, tail. So the number of favorable outcomes in this case are 7 and the total number of outcomes are 8. Therefore, probability that at most 2 heads is given by 7 upon 8. This completes the fourth part. Next, let us find out the probability of no head. Now from the sample space, we know that the probability of no head is only one outcome having the outcome as TTT. So there is only one favorable outcome to this event and the total number of outcomes are 8. Therefore, probability of no head is 1 upon 8. Proceeding on to the next part, in which we have to find the probability of 3 tails. Now there is only one outcome having 3 tails, which is TTT from the sample space. Therefore, the number of favorable outcomes for this event is 1 and the total number of outcomes are 8. Therefore, probability of 3 tails is also 1 upon 8. Now let us find the probability that exactly 2 tails are there. So the outcomes for this event are HTT, THT and TTH from the sample space. So the number of favorable outcomes for this event are 3 and the total number of outcomes are 8. Therefore, probability that exactly 2 tails are there is 3 upon 8. Now let us find the probability of no tail. From the sample space, the outcome for which there is no tail is only one, that is head, head and head. So the number of favorable outcomes for this event is 1 and the total number of outcomes are 8. Therefore, probability that no tail is there is 1 upon 8. Finally, let's find the solution to the last part. That is probability of at most 2 tails. At most 2 tails means that the number of tails is less than or equal to 2. So the outcomes for which there are at most 2 tails are H, 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 T, H, 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 T, T, H, H, then we have H, T, 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 H, T, and then T, T, H. So for all these outcomes, the number of tails is less than or equal to 2. So the number of favorable outcomes to this event are 7 and the total number of outcomes are 8. Therefore, the answer to the last part is that probability that at most 2 tails are there is 7 upon 8. This completes the solution. This question says, if 2 upon 11 is the probability of an event, what is the probability of the event not A? Let us begin with the solution, and here we are given that probability of an event is 2 upon 11. So here we are not given that the event is A, let it be A. So we are given that probability of the event A is 2 upon 11. We have to find probability of the event not A. So this is quite a simple question, since probability of not A is given by 1 minus probability of A. So this is equal to 1 minus 2 upon 11, which is equal to 11 minus 2 upon 11, which is equal to 9 upon 11. Therefore, our answer is probability of the event not A is 9 upon 11. This completes the solution. A letter is chosen at random from the word assassination. We have to find the probability that the letter is a vowel or consonant. Let's begin with the solution. And the given word is assassination. So first let us find the vowels and the consonants of this word. Now the first letter of the word is A, which is a vowel. Then we have two S, which are consonants. Then again we have A, which is a vowel. Then we have two S, which are consonants. Then we have I, which is a vowel. Then we have N, which is a consonant. Then we have A, which is a vowel. Then we have T, which is a consonant. Then we have I and O, which are two vowels. And then we have N, which is a consonant. So the total number of vowels in the word assassination are 6 and the total number of consonants in the word assassination are 7. Now the total number of letters in the word assassination are 13. And when a letter is chosen at random from the word assassination, then the total number of possible outcomes are 13. Now let us find the probability of getting a vowel. Now this is equal to the total number of favorable outcomes that a vowel is chosen, that is 6, divided by the total number of possible outcomes, which are 13. Therefore, probability that a vowel is chosen is 6 upon 13. Now let us find the probability that a consonant is chosen. Now The number of consonants in the word assassination are 7. So the number of favorable outcomes to this event is 7 and the total number of outcomes are 13. Therefore, probability that a consonant is chosen is 7 upon 13. So this completes the solution. This question says that in a lottery, a person chooses 6 different natural numbers at random from 1 to 20, and if these 6 numbers match with the 6 numbers already fixed by the lottery committee, he wins the prize. What is the probability of winning the prize in the game? Let's begin with the solution. Now, we are given that out of 20 numbers, a person chooses 6 numbers. Then this can be done in 20 C6 ways. And out of these numbers, there is only one choice which will match the lottery committee. Therefore, in this case, the number of favorable outcomes of winning the prize is 1. Therefore, probability that the person wins the prize is given by the total number of favorable outcomes, that is 1, divided by the total possible outcomes, which are 20 C6. Now let us find the value of this number. This is equal to 1 divided by 20 factorial divided by 6 factorial into 20 minus 6 factorial, and this is because we have the formula NCR is equal to n factorial divided by r factorial into n minus r factorial. Now let us simplify it further. So this is further equal to 6 factorial into 14 factorial divided by 20 factorial. So this can be written as 6 into 5 into 4 into 3 into 2 into 1 into 14 factorial divided by, now 20 factorial can be written as 20 into 19 into 18 into 17 into 16 into 15 into 14 factorial. Now 14 factorial cancels out with 14 factorial. Now let us simplify it further. 5 4s are 20. 20 cancels out with 20 in the denominator. Now 6 into 3 is 18. So this cancels out with 18. And 2 8s are 16. So we have 1 divided by 19 into 17 into 8 into 15. And this is equal to 1 divided by 38760. Therefore, our answer is the required probability that the person wins the game is 1 divided by 38760. This completes the solution. In this question, we have to check whether the following probabilities PA and PB are consistently defined. Let's begin with the solution. And in the first part, we are given that probability of A is 0.5, probability of B is 0.7, and probability of A intersection B is 0.6. Now, we know that A intersection B is a subset of the set A. This implies that probability of A intersection B is less than or equal to probability of A. But here, probability of A intersection B 0.6 is not less than or equal to the probability of A, which is 0.5. Hence, for the first part, probability of A and probability of B are not consistently defined. Now let us move on to the second part. In the second part, we are given that probability of A is 0.5, probability of B is 0.4, and probability of A union B is 0.8. Now, first let us find the sum of probability of A and probability of B. So this is equal to 0.5 plus 0.4, which is equal to 0.9, and probability of A union B, as it is given to us, is 0.8, which is less than 0.9, which is the probability of A plus probability of B. And we know that probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B, which is less than probability of A plus probability of B, and this condition is satisfied here. Therefore, we can say that probability of A and probability of B are consistently defined. This completes the solution. In this question, we have to fill in the blanks of the following table. Let's begin with the solution. And first, let us understand a formula which says that probability of A union B is given by probability of A plus probability of B minus probability of A intersection B. So using this formula, we will fill up the blanks in the given table. Let's begin with the first one. In the first one, we are given probability of A, probability of B, and probability of A intersection B. Probability of A is 1 upon 3. Probability of B is 1 upon 5. And probability of A intersection B is 1 upon 15. We have to find probability of A union B. Now from the formula, probability of A union B is equal to probability of A, that is 1 upon 3, plus probability of B, which is 1 upon 5, minus probability of A intersection B, which is 1 upon 15. Now the LCM is 15 in this case, and the numerator we get 5 plus 3 minus 1, which is equal to 7 upon 15. Therefore, probability of A union B is 7 upon 15. Now let us solve the second part. In the second part, we are given probability of A, which is 0.35. Also, we are given probability of A intersection B, which is 0.25. We are also given probability of A union B, which is 0.6. Now, substituting the three values in this formula to get the probability of B. Probability of A union B is 0.6, and this is equal to probability of A, which is 0.35, plus probability of B minus probability of A intersection B, which is 0.25. So this implies that 0.6 is equal to 0.35 minus 0.25 gives 0.10. plus probability of B, which implies that probability of B is equal to 0.6 minus 0.1, which is equal to 0.5. Therefore, probability of B is 0.5. Now let us find the solution to the third part. In the third part, we are given that probability of A is 0.5, probability of B is 0.35, and probability of A union B is 0.7. We have to find probability of A intersection B. Now, substituting the values of probability of A, probability of B, and probability of A union B in this formula, we get 0.7 is equal to 0.5 plus 0.35 minus probability of A intersection B. This implies that probability of A intersection B is equal to 0.5 plus 0.35 minus 0.7, and this is equal to 0.15. Hence here we have 0.15 as the probability of A intersection B. So this completes the table and the solution. In this question we are given that probability of A is 3 upon 5 and probability of B is 1 upon 5. We have to find the probability of A or B if A and B are mutually exclusive events. Let's begin with the solution. We are given that probability of A is 3 upon 5 and probability of B is 1 upon 5. Also we are given that A and B are mutually exclusive events. This implies that A intersection B is an empty set. That is, A and B are two disjoint sets. This implies that probability of A intersection B is 0. Now we have to find probability of A or B, which is also equal to probability of A union B, and its formula is probability of A plus probability of B minus probability of A intersection B. Now probability of A is 3 upon 5 plus probability of B is 1 upon 5 minus probability of A intersection B, which is 0. So this is equal to 4 upon 5. Hence, the required probability is equal to 4 upon 5. This completes the solution. In this question, we are given two events E and F such that probability of E is 1 upon 4, probability of F is 1 upon 2, and probability of E and F is 1 upon 8. We have to find the probability of E or F and the probability of not E and not F. Let's begin with the solution. And we are given that probability of E is 1 upon 4, probability of F is 1 upon 2, and probability of E and F is 1 upon 8. First we have to find probability of E or F. This can also be written as probability of E union F, and its formula is probability of E plus probability of F minus probability of E intersection F. Now probability of E is 1 by 4, probability of F is 1 by 2 minus probability of E intersection F, which is 1 upon 8. Since probability of E and F is nothing but probability of E intersection F, On simplifying, we get the LCM 8. In the numerator we get 2 plus 4 minus 1, which is equal to 5 upon 8. Now let us find the probability of not E and not F. So this is equal to probability of not E intersection not F, which can further be written as probability of E union F complement, that is P not E union F, and by De Morgan's law this can be written as 1 minus probability of E union F. Right? And we have already found the value of probability of E union F from the first part, which is equal to 1 minus 5 upon 8. So this is equal to 8 minus 5 upon 8, which is equal to 3 upon 8. Hence the probability of E or F is 5 upon 8, and the probability of not E and not F is 3 upon 8. This completes the solution. In this question we are given that events E and F are such that probability of not E or not F is 0.25. We have to state whether E and F are mutually exclusive. Let's begin with the solution. We are given that probability of not E or not F is equal to 0.25, and we have to state whether E and F are mutually exclusive. Now, E and F are mutually exclusive implies that E intersection F is an empty set, that is E and F are disjoint sets. This implies that probability of E intersection F is equal to 0. So from here we will find probability of E intersection F. If it comes out to be 0, then we will say that E and F are mutually exclusive events, otherwise not. Now we are given that probability of not E union not F is equal to 0.25. Now probability of not E union not F can be written as probability of E intersection F complement. So this is equal to 0.25. This further implies that 1 minus probability of E intersection F is equal to 0.25, which implies that the probability of E intersection F is equal to 1 minus 0.25, which is equal to 0.75, and 0.75 is not equal to 0. This implies that probability of E intersection F is not equal to 0, and E and F are mutually exclusive only if probability of E intersection F is equal to 0. So here we get that probability of E intersection F is not equal to 0. This implies that E and F are not mutually exclusive. So this completes the solution. In this question we are given that A and B are events such that probability of A is 0.42, probability of B is 0.48, and probability of A and B is 0.16. We have to determine the following. Let's begin with the solution. And first let us write down what we are given. We are given that probability of A is 0.42, probability of B is 0.48 and probability of A and B is equal to 0.16. That is, probability of A intersection B is 0.16. Now let us find the first part where we have to find the probability of not A. That is equal to 1 minus probability of A, that is 1 minus 0.42, which is equal to 0.58. Therefore, probability of not A is 0.58. Now let us proceed on to the second part. In the second part, we have to find the probability of not B. And this is equal to 1 minus probability of B. And probability of B is equal to 0.48. So we have 1 minus 0.48, which is equal to 0.52. Therefore, probability of not B is equal to 0.52. Now let us proceed on to the third part. In the third part, we have to find probability of A or B, and this can be written as probability of A union B. And the formula to find the probability of A union B is probability of A plus probability of B minus probability of A intersection B, that is A and B. So this is equal to 0.42 plus 0.48 minus 0.16, and this is equal to 0.74. Therefore, probability of A or B or A union B is equal to 0.74. This completes the solution. In this question, we are given that in class 11th, 40% of the school students study mathematics, 30% study biology, 10% of the class study both mathematics and biology. If a student is selected at random from a class, find the probability that he will be studying mathematics or biology. Let's begin with the solution. And let us denote the subject mathematics by M and biology by B. We are given that 40% of the students study mathematics, therefore probability of M is 40%, or it can also be written as 40 upon 100. And also we are given that 30% of the students study biology, therefore probability of B is 30%, which is equal to 30 upon 100. Also we are given that 10% of the class study both the subjects, therefore probability of M and B, or in other words probability of M intersection B is equal to 10%, which can also be written as 10 upon 100. Now we have to find the probability that he will be studying mathematics or biology if a student is selected at random. Therefore, we have to find probability of M or B for a student. So this is given by probability of M plus probability of B minus probability of M intersection B, and this is equal to 40 upon 100 plus 30 upon 100 minus 10 upon 100, which is equal to, in the numerator, 70 minus 10 divided by 100, which is equal to 60 upon 100, which is equal to 0.6. Hence, the required probability that if a student is selected at random from a class, he will be studying mathematics or biology is 0.6. This completes the solution. In an entrance test that is graded on the basis of 2 examinations, the probability of a randomly chosen student passing the first examination is 0.8 and the probability of passing the second examination is 0.7. The probability of passing at least one of them is 0.95. We have to find what is the probability of passing both. Let's begin with the solution, and first let us define the events A and B such that A denotes the event student passes the first examination and B denotes the event that student passes the second examination. Now we are given that if a student is chosen at random, then the probability of passing the first examination is 0.8 and the probability of passing the second examination is 0.7. Also we are given that probability of passing in at least one of the 2 examinations is 0.95. We have to find the probability that he passes in both the examination. Now passing in at least one of the 2 exams means he passes in A or in B. So we are given probability of A or B is equal to 0.95, or in other words we can say that we are given probability of A union B, which is equal to 0.95. We have to find the probability that he passes in both the examination, that is we have to find probability of A intersection B. Now we know that probability of A union B is given by probability of A plus probability of B minus probability of A intersection B. Now let us substitute the values. Probability of A union B is 0.95. Probability of A is 0.8 and probability of B is 0.7. And we have to find the value of probability of A intersection B. So this further implies that probability of A intersection B is equal to 0.8 plus 0.7 minus 0.95, and this is equal to 0.55. Therefore, probability of A intersection B is 0.55. That is, probability of passing both the examination is 0.55. So this is the required probability, and this completes the solution. This question says the probability that a student will pass the final examination in both English and Hindi is 0.5 and the probability of passing neither is 0.1. If the probability of passing the English examination is 0.75, what is the probability of passing the Hindi examination? Let's begin with the solution. And first let us define the events E and H such that E denote the event that student passes in English and H denote the event that the student passes in Hindi. Now we are given that the student will pass the final examination in both English and Hindi. The probability is 0.5. So we are given probability of E and H is equal to 0.5, or we can say that we are given that probability of E intersection H is 0.5. Also we are given that probability of passing the English examination is 0.75. And we are also given that probability of passing in neither the examination is 0.1. So we have probability of neither E nor H is equal to 0.1. So this we are given. Now this implies that probability of not E and not H is equal to 0.1, which implies that probability of not E intersection not H is equal to 0.1. This can further be written as probability of E union H complement is equal to 0.1, which can be written as 1 minus probability of E union H. So this is equal to 0.1, which further implies that probability of E union H is equal to 1 minus 0.1, which is equal to 0.9. Therefore, probability of E union H is equal to 0.9. We have to find probability of H. Now, we know that probability of E union H is equal to probability of E plus probability of H minus probability of E intersection H. Now probability of E union H is 0.9. Probability of E is 0.75 plus probability of H we have to find out minus probability of E intersection H, which is equal to 0.5. This implies that probability of H is equal to 0.9 plus 0.5 minus 0.75, which is equal to 1.4 minus 0.75, and this is equal to 0.65. Hence we can say that probability of passing the Hindi examination is 0.65. This completes the solution. In this question we are given that in a class of 60 students, 30 students opted for NCC, 32 opted for NSS and 24 opted for both NCC and NSS. If one of these students is selected at random, find the probability that first, the student opted for NCC or NSS. Second, the student has opted neither NCC nor NSS. And third, the student has opted NSS but not NCC. Let's begin with the solution. And first let us define the two events E1 and E2 such that E1 denotes the event student opted for NCC and E2 denote the event that student opted for NSS. Now we are given that probability of E1, that the student opted for NCC, is 30 upon 60, which is equal to half. Probability that the student opted for NSS is 32, which is the total number of favorable outcomes, divided by the total number of students, which is 60. So this is equal to 8 upon 15 on simplification. And also we are given that probability of E1 and E2, that a student opted for both NCC and NSS, is 24 upon 60, which is equal to 2 upon 5. Now first let us find out the probability that the student opted for both NCC or NSS. So we have to find the probability of E1 or E2, which can also be written as E1 union E2. Now according to the formula, this is equal to probability of E1 plus probability of E2 minus probability of E1 intersection E2. Now probability of E1 is half. Probability of E2 is 8 upon 15. And probability of E1 intersection E2 is 2 upon 5. So on simplification we get in the denominator 30 as LCM. In the numerator we get 15 plus 16 minus 12, which is equal to 19 upon 30. Therefore, probability that the student opted for NCC or NSS is equal to 19 upon 30. Now let us proceed on to the second part. In the second part, we have to find the probability that the student opted neither NCC nor NSS. That is, we have to find not E1 and not E2. So this is equal to probability of not E1 intersection not E2. So this is equal to probability of E1 union E2 complement, and this is equal to 1 minus probability of E1 union E2, and probability of E1 union E2, just now we have found out it is 19 upon 30. So substituting this value, we have 1 minus 19 upon 30. So this is equal to, on simplification, 13 in the denominator, and in the numerator we have 30 minus 19, which is equal to 11 upon 30. Therefore, probability that the student opted neither NCC nor NSS is equal to 11 upon 30. Now let us proceed on to the third part. In the third part, we have to find the probability that the student has opted NSS but not NCC. So we have to find the probability of E2 but not E1. That is, probability of E2 but not E1 is given by probability of E2 minus E1. Now this can be written as probability of E2 minus E2 intersection E1, and this is since E2 intersection E1 is a subset of E2. So this further implies that probability of E2 minus probability of E2 intersection E1. Now let us substitute the value. Probability of E2 is 8 upon 15. Here we have found out that probability of E2 is 8 upon 15 minus probability of E2 intersection E1, which is 2 upon 5. So this is equal to 8 minus 6 upon 15, which is equal to 2 upon 15. Therefore, probability that the student opted for NSS but not NCC is equal to 2 upon 15. So this completes the solution.